for coming back to more of the Sea Lamprey control session. We're going to start this segment of the session with Lisa Walter from the Great Lakes Fishery Commission. Lisa's going to talk to us about sea lamprey control barriers and the threats and opportunities associated with that important part of the control program.
Thanks, John. I'm impressed by the level of energy in the room after on week 2, day 3 of the meeting, so good to see so much discussion. I'm Lisa Walter. I'm the Aquatic Connectivity Coordinator with the Great Lakes Fishery Commission, and then Chris Freiberger, also with the Commission, and Kevin Mann with the Barrier Program with the U.S. Fish and Wildlife Service contributed pretty heavily to this talk. So just a quick rehash, you've heard a lot about the sort of big 3 risks to the sea lamprey control program right now. Bruce talked about the social license piece, and so did Don in their talks. Aaron just talked to us about lampricide resistance. I'm here to talk about lowermost barrier removal and failure, which is the breakdown or removal of key blocking barriers. So when we talk about lowermost barriers, that term essentially means it separates the river from the lake. So it stops sea lamprey from passing. It also stops migratory species from passing. The barriers that provide that separation are critical to continued sea lamprey control. They make lampricide control feasible. The distance to the next upstream barrier, we've got around 50,000 kilometers between the 2 countries. And that's just from the lowermost of black sea lamprey to the next up. That doesn't include if you were to remove every barrier in a stream and see how much river there was for passage. If we lost, or if we had to treat those 51,000 kilometers, that would double the annual lampricide treatment cost. And there's more information about that in a paper that Pete Rohde put together in 2021, which you can access using that QR code. So in the map, the blue is showing the accessible areas, the red is showing areas of rivers that are blocked. So 3 major threats, and they all sort of weave together, but failure is one of them, so that is largely due to aging infrastructure. The average age of these dams around the basin is like 83 years old or something like that. So typically they consider a dam to last 50 years, although that's not like a really firm number. We just know that when they're older than 50 years, they're pretty old. Dam ownership expenses can also contribute to failure. They're really expensive to maintain, they're really expensive to license, and none of those prices are going down anytime soon. And then heavy rainfall events. We've seen, especially over the past 10 years, that we get a lot of rain all at once, especially in the spring pretty frequently, and some of these dams are just sort of not made to withstand that. We're also looking at a threat via removal. So loss of purpose, essentially the dam was constructed for some reason. It's not serving that reason anymore, and so folks seeing the expense and the sort of implications to the habitats, they said, let's take it out. Regulatory and financial challenges, that goes back to those expenses that I talked about. Ecological considerations, we know that dams warm streams, they stop processes in the river, they block migratory species, et cetera. And then funding availability. There's actually been, at least on the U.S. side, a really large increase in infrastructure funding over the past 6 or so years, which has made these removals more feasible. And then I'm going to add one that we don't always talk about very much, but it's become a really significant issue in the past couple of years, which is the sale of dams. Current dam owners will say, hey, I'll make you a deal. I'll sell you this dam for $1. Except then whoever buys it is not set up financially to actually maintain that. And so they will run it for a few years to produce power, and then they will abandon it, essentially. The company that owned it will go under, declare bankruptcy, and then the dam is left standing with no one to maintain it. So I don't think this is as much of an issue in Canada, but it's a very big issue in the U.S. I'm sure anybody that's a manager in the U.S. here could name you one in their state right now. So one example, we've heard a couple of times now about this Tittabawassee River failure of Edenville and Sanford dams. This happened in May of 2020. So all of the, you can see all of the sediment that washed out when these 2 dams failed. So this was a really large rain event that dumped about 8 inches of rain in Michigan over about 24 hours. You can see the city of Midland down here. Pay attention to that for the next slide. And so I was at a dam removal workshop a couple of weeks ago, and somebody was talking about how when you remove a dam, you see fish start to sort of move through where the dam was removed within about 3 to 4 years. So this figure, Dan McGarry from the Fish and Wildlife Service put this together. It's actually showing how sea lamprey moved through the system within just 1 year. So they used to be stopped here at Sanford Dam, and it's not super obvious, but there's a red line that traces all the way up here, and that was how far they moved in 1 year. So assessment costs are added then to the sea lamprey control program to find them. How far upstream did they move? Do we need to treat the area? And then the answer was yes. That treatment cost $661,000 US to conduct. So that's an area that's never had to be treated before because the dams blocked the sea lamprey prior. So that was the first year, and then this is as high as the lamprey reached. And so we've got that same stretch, and then you're seeing they're starting to branch out into the smaller tributaries. Luckily, there's a number of dams there that will eventually stop them, but again, it's not, it's still adding quite a bit of effort to the program. And then another example, 6th Street Dam in Grand Rapids. It's downtown Grand Rapids. It's a sea lamprey blocking structure. The same storm that caused the failure of those Tittabawassee dams also raised the Grand River to the point where the dam was inundated. So when we talk about dam failure, it's not necessarily just that it washes out completely and it's never there again. It's sometimes the rain is just such that it makes the barrier ineffective, right? It's not blocking sea lamprey anymore because there's so much water. And so you see this spike at the gauge station, which again, it corresponded perfectly with what happened at the Tittabawassee, and it was, oh, okay, we had 30,000 CFS in a system that's only going to block lamprey up to 24,000. So sea lamprey were found upstream of that barrier in 2022, and then had to be treated in 2023 at just under 150,000. So again, more failures don't always look like these huge catastrophic events. Sometimes it's just things like this. Another threat that we have going on right now, Consumers Energy is a company in Michigan that right now owns 13 hydro dams on 5 rivers. Originally, they owned over 90 dams across the state, and they've slowly sort of sold them off. 4 of those dams are lowermost sea lamprey blocking structures. Those are what's circled in purple. Circled in purple. Oh my gosh. It's touchy. So one on the Kalamazoo, one on the Muskegon River, one on the Manistee, and one on the Ossabaw. Anyone familiar with Michigan rivers knows these are 4 really big rivers who are huge numbers of sea lamprey production is possible in those 4 rivers. So these are really important dams. A 5th, Weber Dam on the Grand River. It's upstream of that 6th Street Dam that I mentioned previously, so it's not technically a blocking structure, but we have an ongoing project there where it could be important in the future. And so Consumers Energy is essentially saying it's not economically valuable for us to continue to produce power at these dams. And so what are we going to do with them? They all are relicensed in like 2037 or later. So they're starting to think about relicensing and what do we do there. And so they came to the communities and said, we're looking at 3 options. We're going to relicense. It's a considerable expense to do so. A new license would go for 30 to 50 years, and they would continue to operate the dams and produce power, even though they're not seeing a lot of economic benefit from that. They would sell the dams to a power producer. They did have folks approach them wanting to buy the dams to remove the dams, and they were not open to that idea. So, and then the third option is that they would decommission or remove the dams. This is a really big deal to the communities around these dams because they have built up their sort of economy and lifestyle around the impoundments. And so to lose those impoundments is a pretty big deal. And there was a series of, I went to like 20 meetings about this past year where different communities were engaged to give some input on that. So where we stand right now with this, Consumers Energy issued a request for proposals in January of 2024. Basically, they wanted to know if anyone was interested in buying the dams. They were going to sell some or all of them, but they wanted to group them by river. So the Ossabaw River has, I think, 6 dams, and they all have to work in concert, essentially. You can't have somebody owning one and then somebody else owning another because they all have to work together. So they didn't want to sell them piecemeal, but they also realized somebody might not want to buy all of them. They did get a few proposals that were viable, which I was kind of confused by, because if they can't operate them in a way that makes sense economically, who can? But they said that they had some proposals, especially from North American companies. I think that means Canadian companies specifically, that were interested in purchasing them to produce power. We were hoping to get a decision in the first quarter of 2025 about whether or not they were going to sell the dams or relicense or decommission, and we've been told now that we will probably not get that decision until the end of the calendar year. So stay tuned on what's going to happen here. Something that I thought was really interesting was that the community groups that I was talking a lot with, when we first started having conversations, the worst possible option was that the dams would be removed. And as the conversations progressed and folks continued to remember what happened with Edenville and Sanford dams especially, the worst possible option became sale. They don't trust someone to buy the dams and maintain them the way that Consumers Energy has in perpetuity, in a way that's going to make them feel safe in their communities. So it's been interesting to sort of see that public response, and we will see where it ends up. So I will probably have an update for you in a year or so about what's happening there. So I'm going to switch a little bit now and talk about some opportunities, because for as many threats as we have, there's some really good stuff going on with a lot of folks in this room especially. Collaboration is one. We're doing a lot of investment in infrastructure with the commission especially, through a barrier asset management plan, an infrastructure plan, and then some geomorphology assessments. And then we also have a pretty significant research investment in trying to model trade-off scenarios to give managers decision-making tools, and then looking at selective passage solutions. So, lowermost barrier list, I'll go into this a little bit more, but what you see in the red dots here are those lowermost barriers across the basin. And we're working on discussing those through a bunch of different groups, including the Connectivity Trade-Offs Committee. And so, the idea of this list is that it's a communication tool. We started with 7,000 dams across the basin, and now we're down to 462 that the control agents feel are important to continued sea lamprey control, which means there's like 6,500 dams that can be removed that no one's really going to argue about. So there's lots of places to start for dam removal funds. And so this list of 462 essentially provides a starting dialogue, right, between the control program, agencies, non-government organizations, dam owners, all of that. And the idea is, like, there's going to be some set of that we really need to keep for sea lamprey control. There's a bunch, 6,500, that, hey, go ahead and remove it, and there's not going to be much of an argument here. And then there's a middle ground, right, where there's a realization that there really needs to be good collaboration to find some solutions that can work for a lot of different folks. So there will be discussions coming up at the Lake Technical Committee meetings in July with agencies about that lowermost barrier list, and then we're projecting a Connectivity Trade-Offs Committee meeting in August to continue those conversations. We do have some work going on with the Great Lakes Aquatic Habitat Framework. So this is a product that was developed back in the early 2000s with the University of Michigan under Catherine Rising. And we're working, Jeff Tyson and I are working with the Michigan State University's Aquatic Landscape Ecology Lab folks to update this and add some new layers. So right now, the NHD plus high-res hydrology data set is in there, along with the sea lamprey control lowermost barrier layer. It's snapped to that NHD plus layer, and we're looking to add functionality soon that includes sort of the next level of barrier, so it's not just the lowermost, it's a more complete data set. We'd like to add a tracing function so that you can click on a point in a stream or click on a barrier and measure upstream and downstream what the river length is. That's something we've heard that's really valuable to our partners. And then a story map where you can interact with it pretty well. So stay tuned for that, but the web address is easy, glass.org, and also you can access it with that QR code. An effort that's been going on in the US program is that after those lowermost barriers were identified, they sent out letters to do an owner survey. So they essentially found contact information for the 360-something dams on the U.S. side and sent them a letter saying, did you know that your dam is important to sea lamprey control? And we would like to know what your future plans are for this. So they actually got quite a few responses. I don't remember the total response rate, but it was 80% plus, I believe. It took a lot to get there. They took, they had to do a few mailings and do a few phone calls, et cetera, do some door knocking. But they've had quite a bit of luck, and so they're trying to work with those dam owners to just say, to let them know about the importance of their structure. There's another example of collaboration that's going on right now on the Sucker River, which is in Grand Marais, Michigan. So there's a perch culvert that has blocked fish and sea lamprey for years. This is a project where 10 years ago, if the state would have come to the control program and said, we want to remove this, the control program would have said, no way, that blocks sea lamprey, we don't want it touched. Again, working on that collaboration, there's going to be essentially the culvert's going to be replaced with a bottomless culvert, so there's good passage there, and then there's going to be a barrier built further upstream. So the important thing here to note is that the distance between where it is now and where it's going, you can see that the stream's not really dendritic there. You have one river, right? You don't have branches, and so it's easier to treat for sea lamprey. And they're going to build a new barrier downstream of where the stream starts to branch and block sea lamprey there, but open a little bit more habitat for fish. So State of Michigan and the Fish and Wildlife Service are both really, really excited about this project. More opportunities. I mentioned a barrier asset management plan and an infrastructure plan. That's kind of central to the commission service and DFO, just realizing that we have a lot of essentially infrastructure really important to the program, and we kind of need to keep track of it maybe a little more than we have been. So this is strategic planning. It's going to guide project management, funding, and partnerships, and then we've also received some funding directly from Congress to address some of these projects in the U.S. and are working on Canadian funds as well to carry out projects in this plan. And then Chris Freiberger is really big on this work about geomorphic assessments, so it's basically looking at a river and a structure in a river and saying, how can we assess risks and liabilities and maintenance needs if we're going to replace a structure with something else? We need to look a little bit beyond, this is a good spot to put a barrier in a river. We need to consider head cutting and channel changes and all sorts of things so that our maintenance needs and our risks are less going forward. And we're also realizing that our partners might find this information really valuable. So lake folks, tell your stream folks that we're going to be starting this work and they might be interested in the results that we find. Just a little bit more, I know I'm running out of time here, but we're doing some research to look at what happens to lake-wide populations of sea lamprey if dams are removed. Heather Dawson is leading that work through the SLAMS model. And then also a case study to predict fish production in newly opened habitat. So Kelly Robinson is working on that. We're continuing to essentially, like I said, build this tool to evaluate trade-offs. This is looking at 6 different species, and it's building off of habitat suitability work done by Emily Dean for her PhD work, and then Shane Flynn, who took that habitat suitability and then built individual-based models for the 6 species on it. So it gets into more technical details than I am super aware of, but these individual-based models include equations for mortality, movement, larval area, recruitment, carrying capacity, and growth. So they're pretty complex, but again, trying to look at production if we remove a barrier for those 6 species. And then we're doing some site evaluation and feasibility work at Consumers Energy dam sites through the Great Lakes Fisheries and Ecosystem Restoration Program, and modeling to predict required sea lamprey barrier size on those too. So again, more of a communication tool with our partners for that. Andrew gave a presentation yesterday about fish paths, which is looking to find win-win fish passage solutions. If you haven't been to the website yet for it, I would scan the QR code and go to the site because there's a camera showing all of the progress and some videos and lots of great materials there to look at to get more detail. So in summary, barriers are critical to continued sea lamprey control. Risks include dam failure, removal, and sale. There's ongoing efforts to identify barriers, develop communication tools, collect agency input, and find collaborative solutions. And then ongoing research to develop evaluation tools and selective passage technology. So that's all I have. The Fish Thief, the documentary about the Sea Lamprey Control Program, is now available to stream on Amazon Prime or Apple TV if you're interested. Family movie night. And that's all I have, and I am out of time.